Hello, welcome to 8.6, choosing a factoring method. So what we're going to be doing in this section is figuring out which method of all the ones that we've learned through chapter 8 should we use, and then also how we can sometimes combine multiple methods when we're factoring. So kind of the steps to follow. The very first thing you should always do is look for a greatest common factor, and that's the first factoring method that we learned. So once you see a polynomial, look to see if there's a greatest common factor, and if there is, factor it out. Once you've done that, then you can start to look for the patterns that we talked about in 8.5. Is it a difference of two squares, or is it a perfect square trinomial? If it is one of those, it can those shortcuts can help you out. Then, if it's still a trinomial, we'll use our factoring methods for trinomials. So remember, if there's not a number in front of x squared, we just look at the factors of c that add up to b, and then if there is a number in front of x squared, we use our method where we do a times c and then find the factors that add up to b. And then once we've done that, our final step is again look for common factors that we may have missed, and if there are any left, again factor them out. So what we're going to be working on is factoring it completely. And here's some examples. So here I have 10x squared plus 48x plus 32. So the first thing I want to do is see if there is a greatest common factor. And I notice here that all of these are even numbers, which means that 2 is going to go into all of them. So I'm going to factor a 2 out first. So I'd have 5x squared plus 24x plus 16. Okay. Now you can see here I have a trinomial, and I have a number in front of x squared, so I want to do a times c, so 5 times 16, which is 80, I believe. And then I want to find the factors of 80. They're going to add up to 24. Well, my first thought is 10, 8, but that doesn't work. That only adds up to 18. 16, 5 is obviously a factor, but that's only going to get me to 21. What about 20 and 4? I think that'll work. So remember, with our factoring method here, we'd put both of those over a and reduce if we can. So 20 over 5 is 4 over 1, and then we're going to put our x's in. So I have to keep my 2, don't forget about the 2, and then I have x plus 4, and I have 5x plus 4. Okay, and then again I'd check to see if there's any other greatest common factors I could get out of there. It doesn't look like it. So I have now completely factored this expression, or this polynomial I should call it. Alright, let's look at another one. Okay, so now I have 8x to the 6th y squared minus 18 x squared y squared. So again, remember, the first thing I do is I look for a GCF. I see in the 8 and the 18 I could take a 2 out. Also notice that I have x squared as a GCF. I also have y squared. And again, just like before, if I didn't know that, I could list out my factors and find the prime factorization of each, and then find their GCF. So if I factor out 2x squared y squared, that's going to leave me with 4x to the 4th minus 9, and that's it, just 9. Okay, now notice here, what I see is I have difference of two squares. This is going to be 2x squared times 2x squared, and this is 3 times 3. So I'd have 2x squared y squared, and then since this is a difference of two squares, I'd have 2x squared plus 3 and 2x squared minus 3. I'll look it over real quick to see if there's any common factors in my parentheses. There's not. So now this is completely factored. Alright, let's look at another few more here. So 4x to the third plus 16x squared plus 16x. I notice that these all have 4x in common. So if I factor a 4x out, I'd have x squared plus 4x plus 4. Then I notice that this is a perfect square trinomial. Notice here we got perfect squares at the beginning, and then this is 2 times 2x, so that's going to work. So I know right away, again, I can't forget my 4x, that's probably one of the biggest mistakes. And then this is a perfect square trinomial, x plus 2 squared. Okay? If I look at this one, again, GCF, I see I can take out a 2, and I can take out a y. And that's going to leave me with x squared minus y squared. So again, I notice difference of two squares, right? XX, YY. So I have 2y in front, and then I have x plus y, x minus y. So as you can see, we're finding GCFs first. That's one of the main differences. And then continuing to factor using either how do we factor trinomials or difference of two squares and things like that. Now, in your book, there's a table that looks like this. And I don't know if this is helpful to you or not. You might want to put it in your notes. But this is kind of a step-by-step thing to help you as you're looking at things to factor. So first of all, any polynomial you come across, you want to first of all look for a greatest common factor and get those out of there if you can. Then if what you have left is a binomial, look for difference of two squares. If it's not difference of two squares, you probably can't do anything further to it. But if it is, then you can factor it further. If what you have left is a trinomial, then again, we're going to use our factoring methods that we learned for trinomials. And then if you come across polynomials that have 4 or more terms, remember that we can factor those using our grouping method that we learned earlier in chapter 8. So when you see 4 or more, you're automatically going to be thinking grouping. Okay? So that's 8.6, and that wraps up chapter 8 for us, and I'll see you guys tomorrow.